Welcome to our library talk, The Shift Towards a Library of Data. Unfortunately, today from Berlin and not as we planned from Switzerland. I'd firstly like to thank Lena Oetjens for the invitation to participate in this wonderful series and for her great efforts, which made it possible to give this talk today despite of the difficult circumstances. My name is Esther Chen. I'm the head of the library at the Max Planck Institute for the History of Science. And I brought today with me my colleague Florian Kräutli, who is the head of research IT, also here in the Max Planck Institute for the History of Science. Let me make some introductory remarks about the situation of libraries today before we will introduce our institute and one of our main projects, our digital research infrastructure, to you. Florian will give you later on a closer insight in one of our long-term research projects here at the Institute, which played an important role in shaping our digital research infrastructure. I assume that we all agree that libraries are currently midway through a long phase of transition. Under growing influence of digitization, our fields of work nearly all changed, and we are facing new tasks and have to build up new expertise. Libraries, as we experience it, have become more deeply involved in the process of scholarly publication, whether if they negotiate open access contracts with publishing houses, for instance, or if they give consultation to scholars in order to choose the best way of open access publishing. Libraries are constantly developing new services and have done so over the past years, such, for example, as copyright and permission requests, such as digitization on demand, and sometimes even more important, a preparation of full texts for DH projects, and there are many, many more. There would have been multiple options today to talk about changing fields of work in libraries and many examples to choose, also when it comes to our library. The reason why we chose the shift towards a library of data is that in our eyes, the diversification in the formats of scholarly outputs, which you could all group under the term of research data, has a huge effect on libraries and on their workflows as well as their technical infrastructures. And we therefore like to introduce our practical approaches, our experiences, our progress, as well as many challenges to you, which we experienced over the past years while dealing with research data in our institute and managing research data in our institute and building up an infrastructure for it. And I am looking very much forward to discuss this topic with you later on. So, I'd like to introduce quickly to you our institute. It's the Max Planck Institute for the History of Science, and it is one of more than 80 Max Planck Institutes, mainly based in Germany, some of them also in Italy, one in Luxembourg. And we are dealing here with a very broad field of scholarly work. It covers basically all disciplines, and we are also facing a very wide time range. We have sources and projects which reach from cuneiform tablets up until to recent history of physics. We are as well experiencing progressing globalization of the history of science towards East Asia and the global South, which means we are dealing with many languages, with many regions, as well as sources and data in non-Latin alphabets. Per year, approximately 350 researchers are coming to our institutes to conduct their projects here with our help and our services. Now I'd like to introduce you quickly our library. Our library plays a major role in the scholarly life of the Institute. It takes up one whole floor here in the Institute, which is about 1/3 of this main building. And you see here a picture of our rare book room. Our rare book collection contains about 3,500 rare books, and we build it closely along the needs of the researchers here in the house. Most of our rare books are digitized and available online, but the whole print collection here, which contains about 65,000 books in total, is still heavily frequented. We develop different research services in the library, and we are closely involved in scholarly projects, which gives us an enormous advantage when it comes to building new services or new research infrastructures, because we know the requirements of the scholars here in our house very well, and we also know very well the data they are producing and they are dealing with. So next, I would like to give you a quick overview over the organization we are dealing with here, especially about how our research IT and the library, when it comes at least to IT research projects, is organized. The library team is much bigger than you can see here on this slide. So as you see, we are dealing here with different departments as well as research groups and IT service centers. We have a research IT unit, which is next to the library in the center of the Institute, but we do also work with research IT staff, which is based within the departments or within the research groups. And they all together build the research IT group here in the house. So when Florian and I started at the Institute about 5 years ago, we found a mix of legacy projects, of ongoing projects, and new requirements for future projects which waited to be set up. In other words, we had to rescue data, we had to migrate it into a new system, and we wanted to create standardized toolkits for researchers so that we could avoid in the future to deal with dozens of different software formats. We took a closer look at our research data, and we found out that we are mainly dealing with books, printed books or digitized books, book chapters. And when I say digitized, I mean images as well as texts. And the output was very often in form of annotations. And these annotations were usually scattered around in different website projects, which caused the problem that they were not compatible with each other, and it was also very hard to secure them. So we were aiming to build an infrastructure where we could at least secure the sources and the research output and interlink it with each other and make them all together retrievable via one system. The situation in the beginning was pretty much like this, as you can see here. We found that we were dealing with a lack of use of standards when it came to the research projects. We were dealing, as I said, with incompatible data, which is really a shame, especially when it comes to an institute like ours, where we are dealing with such a broad variety of disciplines, which means that it would be very interesting to have the opportunity to merge the data from the different research projects, which could really give new scholarly insights. So that was one of our explicit goals, to make that possible. So we were dealing, as I said, with incompatible data tied to old software, which meant in the next step of course, that this data was about to vanish because we are not able to deal with so many different websites and software systems. So if you look at it from a broader perspective, what we face is that the research life cycle, as we knew it for many centuries even, is cracked and is disrupted, because the research data used in form of publications, in form of printed publications, used to flow back in a stable retrieval and in a stable form of archiving, which was usually taken care of by the libraries. And now we are dealing with all this digital data, with all this valuable digital research data, which lays scattered around at different servers in different formats, which does not flow back in any kind of central retrieval anymore. So that was something we wanted to take care of when we started to build our digital research infrastructure. We chose a research project as a pilot for our digital infrastructure to closely collaborate with and learn more about the requirements and the technical challenges. And Florian will now tell you more about that.
Thank you, Esther. So the project I'm going to introduce to you is the Sphere project. And as Esther mentioned, it has served as a sort of testing ground to try out some of the ideas we had for closing the digital research life cycle and for addressing some of the challenges that we have encountered. And at the same time, I'd like to present it to you today to give an insight into the specifics of what we mean by research data in the humanities. So we talked about the annotations, visualizations, databases, websites. And I'd just like to give you an idea of the specific kind of digital things that we produce here in research projects. So what is the Sphere project? So the Sphere project is led by Matteo Valeriani, who is a research group leader in Department 1. And we're collaborating with other researchers at a technical university, most importantly also the library at our institute, and over the time, uncountable numbers of student helpers who have helped us in aggregating and building this database. So we couldn't do these digital projects at this scale without this team of researchers and students. So thanks a lot. So what do? We focus on a history surrounding a single text. And this is the Tractatus de Sphera by Johannes de Sacrobosco. And it's a 13th century treatise on cosmology. It's only about 30 pages long, but it gave rise to a very successful commentary tradition. So this means that this text has, over a pretty long period of time, been published as university textbooks, along with other texts that were seen as relevant for the study of the field of cosmology. So for example, here's a text from the field of astrology, which was included in a 1425 manuscript edition of the Sphere. There were also texts on medicine, and this was a field that largely disappeared in later editions. Instead, what we saw was an introduction of mathematics. So here we have a text, an introduction on Euclidean geometry, which was included in the text as a preparation for understanding Sacrobosco's text, which was dealing, obviously, with spheres. So we see by the combination of this treatise with other texts how certain fields of knowledge became important and how they kind of raised to importance, and how other fields, as mentioned, astrology and medicine, more or less left the curriculum. So far, we collected a corpus of 356 editions, printed editions, in which either the original text appears, or the text appears in a commented form, or that books are closely related to the text. This can be, for example, preparatory material for exams. And we cover a time frame of roughly 180 years, so from the first printed edition in 1472 until mid-17th century, when, as you see here in this histogram down there, the relevance of this text started to decline. And we collected text from all over Europe. We also found one text from Mexico City and one book published in China, which we left out from this map because mostly it's kind of representative of the European knowledge area. What is our question? Our overall question is to find out how scientific knowledge evolved. So how was this specific text disseminated over Europe? Who was responsible for the dissemination of texts? So who decided, for example, which books, which texts to include and which ones to exclude? Which texts have been successful in a sense that they have been published and published again? And who or what was responsible? So was it the language? Was it the place of operation? Was it maybe social connections between publishers? So these are all things we're trying to find out with this corpus. And to do so, we capture certain things about this corpus. So we call this our atoms of knowledge. And first thing we capture is bibliographic data. So data on authors, publishers, printers. And all the data that we produce, starting with this bibliographic data, is stored in RDF format. So this is a linked data format. I'll talk about it a bit later again. I also mentioned the text parts. So these are individual texts, of which the Sacrobosco's treatise is one. And we have so far identified 536 text parts. This includes what we call original texts, as well as what we call adaptions. An adaption can be, for example, a commentary on a text or a translation of a text, or what we also found, a commented translation of a text or a commented commentary of a translation of a text. So all these kind of different ways that a text can be included. We have begun and almost completed the identification of tables. So these texts also contain tables. Some of them are more for organizing information. Others are for calculating astronomical data. So we have a lot of numerical tables that are included, and we can also, or we hope to be able to trace which tables have been reproduced, and in a sense also which tables have been copied, for example, from one book to another. And as you can see, some of these pages are very richly illustrated, and we have manually annotated, and when I say we, I mean mainly our student workers, have manually annotated all these illustrations that appear, almost 30,000 visuals, and about 20,000 of them we classified as content illustrations. The other visuals include title pages, initials, as well as decorative animals. So how have we created this data? We're continuously creating more. So we're using a custom front-end tool built on ResearchSpace and MetaFactory open platform. This is what you can see here. We have also a public version online. And it basically looks like what you expect a database to look like. You can navigate a corpus. You can also navigate to individual book pages. You can see the parts, you can see the persons. So this is what our researchers usually work with. Now, underneath all this is, as I mentioned, a RDF database and a CDOC CRM data model. RDF stands for Resource Description Framework. So this is a linked data format, which allows us to store data, not, for example, in a data table, but in a format where we link individual things and concepts to each other. And this is kind of a standard for the web of data. This means that we can produce data that links to other resources on the web, but it also means that we can produce data that stands on its own. So as Esther mentioned, we have often the problem that we create data within a certain software, and then we have to maintain both the software and the data to keep it usable. Using linked data, we can make data that can basically live on its own on the web without any specific front end. The other building block is CDOC CRM, and this is a model developed for the cultural sector to represent cultural data. And what this allows us to do is to model what we want to represent in very great detail. So it's built around the concept of events. So something happens, and this, for example, something produces a book, and we have certain people involved in that process. And this is how we can model historical processes and later analyze it. And what you see here in the slide is one of our earliest data models, because it was very much also a learning experience for us. So when we started, we didn't know, or at least also I didn't know too much about RDF, linked data, CDOC, CRM. So really also we had to not only learn about what we want to represent in data, what our research questions are, but also how we do that in RDF and CDOC, CRM. And so this was a process that is still ongoing, where we just developed step by step our data model in accordance to what we learned about our sources, in accordance to what we figured out we would like to ask our data. And it's pretty much stable now, and but we keep adding more things. For example, when we start identifying tables, we need to include this in our data model. And it's incredibly complex by now, which is why we more or less hide it from the researchers and from everyone who works with. So this is, again, our database interface. And I'm now showing you how we input the data, which is pretty much just through standard forms. So there's drop-down menus. Basically also what you would expect from a database interface. We have the ability to add place information, and we link this place information to Wikidata as a sort of global authority database. We have a database, obviously, of people, which we can then link to these books. So this is pretty much how data is input. However, underneath this is a RDF triple store, which in the background then generates these triples, fills this model with data in order that it is kind of expressive enough to be useful also when probably in a few years this database is no longer maintainable in its current form. I also mentioned the images. So this is how we capture the images. Basically, they are annotations on IIIF images. So IIIF is a standard interface for retrieving images. And using this interface, we can describe illustrations as certain regions on a page that is digitized. And in this way, we also keep this linkage between an individual illustration that we identified, the page where it is on, and finally the book that this page is a part of. So now we generated all this data. What do we do with it? We start with exploring it. For example, the images, we can use visualization tools. And this is a tool developed by students at the Fachhochschule in Potsdam, originally for a numismatic collection. And we adapted it to visualize our 30,000 content illustrations. So what you see here is a timeline view. And you see vertically, we separated the illustrations into similar illustrations. What we discovered here is, for example, that there is a shift in illustrations around 1530. So lots of content, lots of text has not been illustrated before, and then received an illustration after 1530. So this is something we discovered through this way of visualizing the images. And again, this is research data visualized in a tool, and the visualization itself is also probably a form of research data, but one we might not be able to maintain in its original form. Another visualization tool, which, as it so happens, also was developed at the Fachhochschule Potsdam by Christopher Peach, is a timeline visualization tool. And again, it allows us to interrogate our data, our visual data, for example, here also by place of origin. And this one really allows us to kind of have a broad view at the data, but also zoom in on individual illustrations. And what is also available here is a similarity view. So we can look at a similarity among images, and this, for example, can tell us which images have been reoccurring, which images have been maybe been more successful. We categorize some of them. So this, for example, with the keyword water. So this is all ways that we start to just work with this data and see what we've got. Our main research question I mentioned in the beginning is that we are interested in how certain parts were successful or unsuccessful. So which texts have been republished over and over again, and which texts have been maybe not so successful. So this was an initial visualization done by Dan Lockhorst, which shows parts that have been republished, parts that have been published only once and then never again, and parts that have been published for the first time and then have been republished later on. So this way we start to identify periods of innovation and periods of where, say, content was recycled more or less. So this gave us kind of an overall view, but we also realized that we need a more custom, in-depth look at this. So we designed a visualization which is basically a network matrix. So we have the books going horizontally and the text parts going vertically, and we place a dot whenever a text appears in the book. And this allows us, as you can see, to see the connections between individual parts and books and see which parts have been published, have been more successful and have been published over time. So the whole kind of top left part of text, as you see there, has been more or less unsuccessful and has not been republished for the most part after around 1530, at which point the text that I just highlighted was introduced, which has been really successful and has been published over and over again in books up until the end of the time frame covered by our corpus. So this is something that we discovered through network analysis, through visualization, through going back and forth with our data. And we also published a paper. So we did, say, close the traditional research life cycle in the sense that we published a paper that can go into the library, that you can cite. But really, what happens to everything else we produce? What happens to all the data? What happens to all the images, to all the visualizations? And this is what we try to solve with our digital research infrastructure, which I now let Esther introduce.
Yeah, thank you very much, Florian. I think this research project, showing this research project to us, showed very explicitly what the requirements are when we talk about a shift towards a library of data. Because as you have seen, what happens in these kind of, as you can maybe put it, DH research projects is what Florian called to deal with atoms of knowledge, to have a huge workflow and ongoing process of data creation. So the requirements for the library and of course also for the research IT are to deliver the data in certain formats, as well as then to take back certain parts, at least, of the research data and store it and to make it retrievable. So we called it here, we scaling it up. Now we go from this micro perspective, from this research project, and see what we will do with it, how we deal with these requirements in order to build a digital research infrastructure. Maybe what have we learned first? So this pilot project gave us, all of us, I guess, everyone involved, a great learning experience. It was very important for us to do this project and to also design this project hand in hand with the research projects. Because as you could see in this project, also the scholar was dealing for the first time with linked data, which means that we provided a certain toolkit which was being used from the beginning of the research process on, and which gave us all the opportunity to find out together how to deal with the data modeling, what is crucial to model for the scholarly process, and what is important to learn in this context for the research IT, and what can the library provide, and how can the library help in this process. So what we learned is a nice success, because we saw that at least on this scale, linked data inside of CRM is doable. We put a lot of intellectual work inside of it, as Florian described, but this is something which has to be done as an initial process, and it has not to be done in that intensity over and over again. So the second thing we learned is that IIIF is great. I cannot say so much about it, so I think it speaks for itself. And another point is that, very crucial point, is that we have to separate the data from the software, as Florian mentioned, because otherwise we will not be able to secure the data and to at least maintain the data. Imagine, I said in the beginning that about 350 researchers go through our house every year. Of course, not every one of them is building a website or is building a bigger kind of digital research project. But I guess about 10 to 15 ongoing projects we have per year. So we cannot maintain them forever. Our institute, as well as all the other Max Planck institutes, are not meant to host projects on a very long term. Scholars usually leave after in between 1 to 5 years. So we have to find a solution to put also projects to a final rest without losing the data. Something we also learned is that it's very important to use dedicated systems, to communicate via standards with the researchers using them, and that we have to add harmonized access. And last but not least, something I mentioned before, is that we have to design for end of life, because people are leaving here and can usually not take their projects with them. And we do not want to maintain the projects, but we do not want to lose the data either. We designed an infrastructure which contains of 4 components: repository module, 2 working environment modules, and a knowledge graph module. The knowledge graph module is the most innovative part of this architecture, because there we can reach our aim to merge the research data with the research sources. I will show you a workflow now, our digitization and research data workflow, which makes this a little bit more clear. So we start the whole digitization process with Gobi, with our digitization workflow software, which means that here we digitize our rare books, for example, and create metadata in the format of METSMODS and XML. So in the next step, these files are being ingested in our repository, which is based on Fedora. So we put all of our digitized files and the metadata in our Fedora repository. And underneath we have, for the long-term archivation, the CD star system. And again, here we have the viewer, we work with the IIIF viewer. In the next step, the metadata goes through a mapping engine, which was developed by the people basically dealing with CyDoc CRM. in Heraklion, the group of Martin Dörr. So the metadata is being converted and then in the next step being ingested into our knowledge graph. So this would be the data flow and the workflow from one direction. This is how the library data, the data which we create, flows into this knowledge graph environment. Florian said already a little bit about the tech stack before. We are using research space from the company MetaFacts, and we are using Blaze Graph to deal with our RDF data. So from one side of our workflow, we insert the library data into the knowledge graph. From the other side, we insert and ingest the research data. We get research data sets, which are being produced in the various research projects, as Florian described before. And since we cannot and we do not want to maintain the actual research website, which is being produced while the research project is still ongoing, we extract the research data from the project in such a data set after the project is finished. We also map that with this so-called 3M mapping tool, which I have described before, which is made and provided by Martin Dörr and his team. We archive this data in existing data archives, such as daria.de, for example, and then the data is being ingested into the knowledge graph. So at that point, we have achieved our goal, which was to have the data in one retrieval system, every kind of research data which is being produced within the project, as well as the library data, the sources. So in this moment, we can find at the same time certain annotations which have been made on certain sources, which we have and digitize and provide in the library. And it's all in one retrieval system. And of course, the benefit of linked data is as well that we are able now to link our linked data to the outside world, such as Wikipedia, the GND from the German National Library, and so on and so forth, or even to other research projects which maybe deal with similar sources, with similar projects. So that would be the linked open data cloud, which you see on top of our knowledge graph. Here you see how the data flows from both sides into the knowledge graph and is merged and archived and made retrievable there. And a longer term goal is also, of course, to integrate all the data we have, also the library catalog and our publications, our bibliographical database, which we produce here for all the publications made here in the Max Planck Institute for the History of Science, and more or less to insert all the databases which we have and which we produce here in the knowledge graph. So what have we learned besides the technical solutions? One important lesson was that the role of librarians and IT researchers in the research process has changed. IT researchers as well as librarians have to enter the research process at a much earlier state and function as consultants for the research projects and for the scholars when it comes to data modeling, to choosing standards which will be beneficial for their fields of work. Another lesson learned was that the collaboration of library and research IT staff is very crucial for the success of our projects. And we are still in the middle of figuring out where the future responsibilities lay when it comes to data modeling, for example. Up until now, Florian played a major role when it came to dealing with CyDoc CRM, with FRBROO, with this whole data modeling process and setting it up. In the future, we would like the library to take over much more responsibility in this field, because especially as I see it, this is a core responsibility and a core field of work for librarians dealing with metadata, and it has been for decades, if not centuries. So librarians have to take over new responsibilities here and to build up new expertise and gain further knowledge. Those would be the main lessons learned for us, and we will be very happy to discuss that in more depth with you. So we thank you at this point for your attention, and we are looking forward to our discussion.